All right, hey everyone, what we're going to be talking about today is the introduction to transformations, and we're going to focus on translations and dilations. So let's get started. Make sure you're writing down what we got here for the notes. But transformations are translations, which are slides, rotations, which are turns, and reflections, which are flips. They are rigid motions that preserve side length and produce congruent images. Dilations, such as are enlargements or reductions, those are non-rigid motions that do not preserve the side length and produce similar images. So let's take a look at some of these examples. And the first translations, like we said, or the first is a translation. It's a slide. It's rigid motion and congruent. So what that means, it's the same size and shape, and it has a preserved orientation, meaning that all the points are pointing the same exact way. So if you look here, this is pointing up, this is pointing up, C is pointing this way, this C is pointing the same way, B is pointing this same as that. All right, rotation is a rigid motion, which means same size and shape or congruent. But look at the orientation. It's a changed or rotated orientation. So if we were to take this point here, which corresponds to that point, it rotates that direction. And then reflection, same thing, it's rigid motion congruent, so it's same size and shape, which checks for those, but the flipped or reverse orientation. So if you look here at point C, or C prime, excuse me, C here and C prime, they're pointing different directions. This guy's pointing that way, this one's pointing that way, so it's a reversed orientation. And then lastly, for transformations, we have a dilation, which is non-rigid. So those are similar, meaning they're proportional. So they're not the same size, but they are the same shape. All right, so now what I want you to do is you're going to come down here and you're going to look at this graph and you're going to figure out to get from here to here, what do you have to do? So let's pick a corresponding point. So I'm going to pick this point and this point. So what you have to do is, don't we have to go here and then down? So that looks like a slide to me, which is a translation. Now again, let's look at orientation here. I've got here and here, and it looks like it's either this top part is not pointing the same direction, so then you're going to have to narrow it down. Is it going to be a reflection or is it going to be a rotation? And in this case, it looks like it's rotated all around, so go ahead. So this one would be a rotation. All right, I want you to try this one and I want you to try that one. And then we need to talk about some important vocab along with this. You have your pre-image. Your pre-image is your starting image or your original, and it's just written with the letters. But then your image is whatever the result is. So think of that like your new one. Now, when you're doing this, you have, it looks like apostrophes. That is not apostrophe. That's called prime. You say it like a prime. All right. So make sure you get that down. And then translations is slides every point of a figure the same distance in the same direction. So again, congruent figures. So we're going to talk about an algebraic or arrow rule that says what direction to slide the point. So it's important here because this is we're going to need this to build on some of our other skills throughout the year. So the value added to x shifts the point right, and a value subtracted from x shifts the point left. And then a value added to y shifts the point up, and a value subtracted from y shifts the point down. So it's very similar when you're moving on the graphs. It just tells you what direction to go. All right, so we're going to use this arrow rule. So xy results in this minus 5, or x minus 5 and y plus 8 to find the coordinates requested. So all you got to do is just take whatever your x is and substitute it into there, which is what I did right here. And then you take whatever your y is, which would be 2, and substitute it in there. And then once you get that, then you can get B prime. Oops. Oh, hello. Okay, there we go. B prime, which is -1, 10. All right, so look down here. So you're going to do number 2. I showed you a slightly different way. You can just take exactly what they have here. And if you notice, it's -5, so you just take -5 with your x. And here it says +8, so I'm just lining up your x's and your y's right there. All right. Now for number 3, it says, what's the pre-image? So you're going to work backwards. You're going to go the opposite direction. There's 2 ways to do this. One way is just to set it up like an equation where you say originally we had x minus 5, but it ends with 23. So that's why I equaled it 23. So to do this, you would just add 5 to both sides. So notice we're going the opposite direction. So then you'll get x equals 28. And then here, notice it says y plus 8, and we know we ended at 24. So all I did is y plus 8 equals 24. Well, you still have to subtract 8, and then that's where you're going to get your answer there. So go ahead and make sure you write in what f is for your original. All right, and then you're going to do the same thing here, but again, if you notice, I just went the opposite direction. So instead of subtracting 5 like I did here, I'm going to add 5 to the x. And instead of adding 8 like I did to get the image, I'm going to subtract 8 to go backwards and find the pre-image. So go ahead, complete those. And then, so do that one, that one, that one. And then I want you to go ahead and you're going to find the pre-image of each coordinate based off of those rules. All right, now down here, whoops, it's just giving us words. So you're going to translate triangle ABC, 3 units left. So that means you're going to subtract x minus whatever 3, which is what I have here. And then down means goes with their y's. So if it's 4 units down, you're just going y minus 4. So again, it's just telling you what direction to go. So all I did over here was on the graph is I took each point. So A, I'm starting with A. I'm going to go left 3. So I'm going to go 1, 2, 3, and then down. And I landed here at A prime. All right, and then I'm going to do the same thing. I'm going to go, I just realized I just went the wrong way. I was like, that does not make sense. Okay, don't mind me. Okay, here we go. So anyways, let's try this again. So we're going to go left 3, 1, 2, 3, down 4. There we go, A prime. Okay, B, we're going to go left 3, down 4. B prime. And then C, going to go left 3, down 4. For C prime. There we go. All right, so notice, now that I fixed my mistake, so notice the orientation is still the same. And we went 1, 2, 3, down 4. 1, 2, 3, down 4. 1, 2, 3, down 4. So then that's how you graph it. Okay, so you're going to go ahead and you're going to complete this. Just double check on your papers if it's not fixed. On C, make sure you cross out this up and put down instead. All right, and go ahead and graph those on here. All right, now what you're going to do is you're going to do the same thing, but you're kind of working backwards here because it wants to know x, y, what's the rule? So from A, B, C, D to A prime, B prime, C prime. So we're going to look here. Notice the orientation's the same. So we're going to go, you have to start here. So we went 1, 2, 3, 4, down 3. And you're going to figure out if that goes. So you're going to write your rules here. Now here, notice you're going from image to pre-image. So again, you're going to write your rule here, but just pay attention to what directions you're going. All right, and then you're going to write the rules for the given transformation. So again, 7 units left. that's your x. Oops. There you go. And then 4 units down, so your x goes left or right, and your y goes up or down. All right, so you're going to go ahead, you're going to complete these, and then we'll talk about dilations. All right, dilation is made when you either enlarge or reduce a figure. Two plane figures are similar if they are the same shape, but not the same size. A dilation is non-rigid, meaning it's similar to the pre-image. The angle measures are the same, but the side lengths change, so that's very important. Dilations enlarge or reduce a figure. So the scale factor is K. If the scale factor is greater than 1, the figure is enlarged. If K is between 0 and 1, it's reduced. So make sure you're paying attention to that. And then to determine the scale factor, your scale factor is your image over pre-image. So I like to also remember new over original. So whatever works for you, that's fine. So let's look here. Right now, K is greater than 1, so that's an enlargement. And here, K is between 0 and 1, so this is a reduction. So you're going to go ahead, complete those. And then here, you can have a pre-image of these points. And in order to do this, all you do is multiply the scale factor by each point. So if we take 1/2 times 2, you get 1. 1/2 times 4, you get 2. So A prime would be that. And then here we have a fraction. That's okay. You're going to do 1/2 times 5, gives you 5/2. And then 1/2 times 4 gives you 2. And then if it's a negative, that's okay also. So we take 1/2 times -2 gives you -1. 1/2 times 6 gives you 3. So just make sure when you're doing this, you write the rule, and it's whatever you're multiplying the scale factor by. So in this case, both points were multiplied by 1/2. So that's why we do 1/2 times x and 1/2 times y for your scale factor. And in this case, since K is between 0 and 1, it's a reduction. All right, you're going to go ahead and try that one. Horizontal and vertical dilation. So you're either going to stretch or compress, and it's either going to go horizontally, which is side to side, or vertically, which is your y-axis up and down. So let's look here. Your rule is A, is 1/3 times 1, so that gives you 1/3. But y we don't do anything to, so y we just write as is. So now you're going to take 1/3 times -3, and then y you just leave as 2. And then same thing, you're going to take 1/3 times the x, which gives you 2/3, and then y you just write. Now, since it's only the x, it's horizontal, and since it's 1/3, it's between 0 and 1, so then that's your horizontal compression. All right, you're going to try that one. And this last one, you're going to do all of this, and then we'll talk about this later, what you notice about the perimeters and what you notice about the areas. But you're going to go ahead, complete this, and then we'll talk about what you notice. All right, and then that is your introduction to transformations, which would be translations and dilations for this lesson.